So that'll be this one. Y equals x squared plus 8x minus 5. And I'm actually going to change this equation to say plus 15. It'll work out better. Okay, so this is definitely not standard form. We have the y equals, but we don't have the stuff in the parentheses squared. So think about the three ways that we were solving quadratics. We solved by factoring, we solved by completing the square, and we solved by the quadratic formula. Did one of those methods create something squared for us? Yeah, which one created it? Right, the completing the square. So in order for us to make this formula into a vertex form or a standard form, we need to complete the square to do so. Okay, so what we're going to do is we are going to clump our x squared and our x together. So I'm going to write x squared plus 8x. I'm going to leave an empty spot so that I can complete the square. Now when we solve these, what did we do with this 15? We subtracted it to the other side, but we don't want anything on the other side. We just want y. So we're just going to leave it after the parentheses as a plus 15. Okay. Yeah, we won't subtract it over because we don't want this to say y minus 15. We want it to just be y over here. Good, so now complete the square. So if this is 8, what value do we have to add on to complete the square? 16. Okay, now what did we do with this 16 normally? We added it to the other side, but well, not add it to the 15. We'd have to subtract it to the 15. Okay? Because normally we would add this to the other side, but we don't want anything attached to the y over here. So instead of adding it to the other side, it would be the same as subtracting it from the same side. We didn't change our equation here because 16 minus 16 is 0. So we just added some extra things in, but it didn't change the end result of our equation. So is that okay? So it's completing the square just slightly differently by keeping all the extra work at the end. Okay, so then this is y equals x squared plus 8x plus 16. What is that squared? Yep, x plus 4 squared. And then here we have 15 minus 16, negative 1, so minus 1. Now does this look like the quadratic form or the standard form? Yeah, it does. So now here is our vertex form or our standard form. So from here we're going to state all of our different things. Okay, so what is our vertex based off of this formula? Good, it's negative 4, negative 1. Okay, what's our axis of symmetry? Put a little bit more to it, not just negative 4. X equals negative 4, so that it's a line. And which way will this open? Which way?
There's nothing there.
So the number in front of here is positive. Your A is positive because it's a 1, so this opens up.
When we do our homework, do you want us to say if it opens up or down?
Mm-hmm. Yep. Do you have to what? No, you don't have to draw on the axis of symmetry if you can see it without. Okay? So what am I going to plot first here? Vertex. So I'm going to go to negative 4, negative 1. Okay? I'm going to just dash in the axis of symmetry so we can see where this would happen. And then which 2 points are we going to plug in so that we can get this quadratic? So here we're at negative 4, right? So we need 2 points right next to it. All right, that'll work great. Negative 3 and negative 2. Okay, so let's plug in negative 3 here. So negative 3 plus 4 is 1 squared is minus 1, ends up giving us 0. Negative 2 plus 4 is 2. 2 squared is 4, and then 4 minus 1 is 3. So we've got the point negative 3, 0, and negative 2, 3. And then what should I do with those 2 points? Yeah, reflect them across the axis. And then I'll just connect to make my, ooh, that's ugly. That's better. Connect to make the parabola, or the quadratic. Yes?
What do you do then, like you did for the last one, and like it's like y equals and then the actual number there? How do you solve
How do we solve this?
like, okay, y equals and then say there's a 5 there,
Mm-hmm.
and then, yeah, if you're trying to find your y, you like just
Okay, yep, you do the same. You still find this value first. So you would still find, like in this case, you'd go negative 3 plus 4 is 1, 1 squared is 1, and then you would multiply by the 5. You do the order of operations with it. Is that example okay? Okay, we're going to do one more where we have to create it ourselves. You know it already? Y equals negative 3x squared plus 6x minus 1. Okay, now when we completed the square, because this is not in vertex form, so when we completed the square, could we have a value in front of our x squared? No. So we would divide everything by 3. But then once again here, our y's are already alone. We don't want any other numbers over here. Good, so we can just pull it out in front of it. We can think of it as taking the greatest common factor out. We would just take it out of the x squared and the x though. Okay? So I would take y equals, I'd take this negative 3 out of just the x squared and the x. Why? Because before we would divide everything by negative 3, right? So, but we want our y alone. So if we divide this by negative 3, it's still not going to work out.
Why would it be negative 3?
Because the negative 3 is attached to the x squared. So we're going to take that negative 3 out. So then if I take the negative 3 out of the negative 3x squared, what do I have left? X squared. If I take negative 3 out of a positive 6x, what do I have? Yep. 2 minus 2x. So I'm just going to keep the x squared and the x alone, and I'm going to let the minus 1 hang out at the end of the parentheses. This also then allows us not to have fractions. This allows us not to deal with a third, which we would have had to deal with otherwise. Okay? So what do I need to do to complete the square here? Okay, so 2 divided by 2 is 1, and 1 squared gives us 1. So we have to add 1 on to complete the square. So instead of adding 1 to the other side, though, I'm going to subtract 1 here. Now we have to be a little bit careful about this one. This 1 right here is also being multiplied by a negative 3. Because the negative 3 is out in front of the parentheses. So what should I multiply this negative 1 by? The negative 3 as well. Okay, so if there's a number in front of the parentheses, we have to make sure that we multiply it on the other side as well. Why didn't we have to do this for the previous example? There's just a 1 there. That's why we didn't have to worry about it. Okay, so this now gives us y equals negative 3. And then in parentheses, what will this be? X. Minus 1 squared. And then negative 1 minus 1 times negative 3. So negative 1 plus 3, yep, so 2. So there's our vertex form.
Ooh, this one goes down.
Yeah. Okay, so where's the vertex from this one? Is that 1, 2, good. Where's your axis of symmetry?
1.
x equals 1. And which way will this one open? This one will open down because our a is negative. Okay, so we'll start by plotting our vertex first. So 1, 2. You don't have to put the axis of symmetry in there, but I'm going to so that we can clearly see where to reflect it. And then which 2 points would you like to use?
-1 and 0.
Okay. So we are going to use 0 and -1 and then reflect those. So when x is 0 here, 0 minus 1 gives us -1, and -1 squared is 1 times -3. -3 plus 2 gives us -1. So now plug in -1. -1 minus 1 is -2. -2 squared, 4. 4 times -3. -12 plus 2 is -10. So we got 0, -1, and then -1, -10. That one goes off the graph, so I'm just going to put it off the graph a bit. And then reflect these. So reflect this one across. And then once again, you will connect them to draw in your quadratic. Is that okay? All right. There's just one thing I want to ask you. There's one more example. We'll do the last example tomorrow, but I do want to ask you this question. Do you think that this is in standard form? It is in standard form. But why? Right. So there's only an x squared. Is there an x anywhere here? No, there's not an x anywhere, which means that this is really like an x plus 0 squared with an 8 out in front. Okay? So when you just have an x squared and not an x anywhere, that is actually already in standard form. When you do your vertex, though, this vertex would just be at 0 because there's nothing attached to the x, and then the 1 because that's the one out in front. Okay? That's just, there will be a few problems that are like this. You just have to make sure you know that your vertex ends up being there at 0.